We're going to send it a little bit slower. What's it start to do? I want you to write it. Write it down. Write down what you see.
Look, Cooper, if you throw it on that
Part
side
of our job right
throw
now.
it on that side of the table, it's not going to do nothing. And you throw it on this side, and it's not going to do nothing.
It's got to be the fall.
On that side, not in the middle.
Well, there's something about the fact that there's a bump,
Because
right?
on that side, the table's higher. On that table's higher. So
I want you to write it down. Write it down. Write it down. We are in a lab. We are trying to figure this out. So Giovanni wants me to try it right here, right?
No, on that end.
On this end, right here.
Right here. I usually come from this side, it'll slide right out. Come from this side, it'll slide.
What do you mean?
So it
Look,
goes like-
look at the table right there. This table's
So
higher.
go from this?
No, that's coming from my side.
Oh,
come
come
from your
on,
side.
okay.
This go that way.
So come from over here?
Yes, right there.
Okay, be very manual. You have to. Something happened. Quinn likes the velocity to be high on this. All right, so again, everybody should be ready right now. What happens when we slowly push it and it hits the bump? What do we hear? We hear it curving.
That crisp, that curve.
We hear it curving. Let's get our senses right. We hear something, right?
Curve.
Is sound a type of energy?
Yeah.
Yeah. So what do you think's happening as it goes over that bump?
It loses momentum.
It loses momentum. Is like your favorite physics word, is it not, Antonio? In a sense, it doesn't quite lose momentum. It loses its velocity. Why does it lose its velocity?
Because
Because it's active bump by that,
The friction
by a little bump on the table.
Right. So that bump in the table causes it to lose some of its energy, right?
Yeah.
When we keep it on one table, though, it generally keeps its whole velocity, right? It keeps all its
There's
energy.
nothing to change its velocity there. There's no obstacle there. Nothing.
So, that book versus this, right? That book has what force acting upon it that slows it down? Friction. Does that have friction acting upon it?
No.
It does in a little bit, right? Very, very, very small, right? But we just send it down. So this is really demonstrating right here Newton's first law. An object in motion stays in motion unless what is acting upon it?
A resistant force.
An opposite force is acting upon it. There are like 6 pairs of gloves. I would like everybody to come on up, grab one glove. I don't have enough for everyone. I want you to feel what it's like to push this so that you start to get this sense that even though that is a 10-pound block of dry ice, right?
That's 10.
Well, it was 10. It's sublimated in my freezer and in that freezer and everywhere along the way. But I want you to feel what it's like for a mass to start going in motion and to remain in motion. Because that's pretty cool, right?